Last class we are discussed about three-moment equation. Today we are discussed three-moment equation problems. Three-moment equation, you already familiar with that equation. In last class we derive an expression for three-moment equation, and the three-moment equation is only using for the continuous beam analysis. This is the last class review. Then today we go through the problems. First problem is analyze continuous beam APC shown in figure using three-moment equation and also draw the bending moment diagram. Flexural rigidity EI constant throughout. This is the problem. In this problem, we are discussed how to solve this problem using three-moment equation. First of all, write the equation, three-moment equation. In the three-moment equation, you have three parts. First part deals with the fixed end moment values. Second part deals with the moment due to loading portion. And third part also that is deals with the settlement. But the given problem deals only with the moment values not described about the settlement, so we can avoid that term, third term, that is settlement term. So the equation become like this. Then next step, draw the bending moment diagram. First of all, draw the free end moment diagram, that is due to external loading, and it is a uniformly distributed load, so we can see that the diagram like this. The next step, find the maximum ordinate value. How do you find that maximum ordinate value? Using our bending moment equation. For a uniformly distributed load, the maximum value of bending moment will be WL square by 8. Using that equation, W is given. Then using that equation, you can find that value. Then next you want to find the value of area. Then A3. A3 is nothing but the distance. Total distance is given 6 meter, then this value is 3. Similarly, here span BC 8 meter, then value A2 is 3. Then second part is over. Then first part here, one thing is that it's a simply supported beam or a continuous beam. For the span AB, A is a first portion. This A is a simply supported beam. Simply supported beam restrains only vertical and horizontal load values. That is, there is no restriction for the moment. So bending moment is here we considered as 0. Here also it's a middle support, so it have some bending moment value. And again C, point C, it's a end support with the hinged or roller support. It will be moment value become 0. So the equation we want to rewrite the equation using the above terms. Here moment becomes 0. You can draw the figure at the moment due to fixed end moment or bending moment due to support becomes 0 at the point A as well as C, but we don't know the value of bending moment at the support B that you want to find. So first of all, you find out the values WL square by 8 and draw the figure. Next step is find A1, A2, A3, A1 area, then its centroidal distance A2 and its centroidal distance I and I1 I are same, that is moment of inertia. Then HA and HC is not mentioned in your question, so it's become 0. Then the three moment equation become like this. Then substitute the value. Then here MA and MC become 0. Then you have the terms 2MB as well as these two terms, that is area values. Here all are known values, the only unknown is MB. So you can find that value, simply substitute the values, you can find the value of MP. After getting this MP value, you can draw the bending moment diagram like this. You already got the value due to external load. Then add up that bending moment MB value here, you will get the bending moment diagram. This is your bending moment diagram. This is the simplest problems using 3-moment equation. Next one is slight variation. That is next problem. You have to discuss the next problem. This is our next problem. In this problem here, slight change with previous one, that is, analyze the continuous beam ABCD shown in figure. If the support C settle down by 5 mm, take E as 15 kilonewton per mm square. Moment of inertia is constant throughout and is equal to 5 into 10 raised to 9 mm raised to 4. This is your question. Compared to previous one, in this question we have two loads, but it's not a uniformly distributed load, it is a pointed load. And one more thing is, in this question it's mentioned that the support is C is settled by 5 mm. Then that is the second one. Then third one is support C is not a fixed end support. It have some projected beams, and we can call it as cantilever beam, and there is an extra load along that beam. So the methods are same. First of all, you wrote the you will write the equation. In this case, you have to write the settlement also, because the settlement is mentioned in your question. Okay. Then first of all, MA it's a support at the end, and it's a end support, and it becomes 0. But the NC is not a end support. After C there will be a load, so we cannot make it as 0. So you have to find that C, and C is an unknown value. Then B, definitely B also have a moment value, MB is there. Then first next step, we want to find areas. Areas depends on the load, 30 kilonewton and 40 kilonewton, and span AB, it is an eccentric load, so the equation become WAB by L. If the load is act at the middle point, the equation WL by 4. Then you can draw the figure like this. WLAB by L and WL by 4 are the values, and you can draw the figures. Then you will get the ordinate value. Then you can find the areas of this triangle. Okay. Here you want to find next thing is areas A1 and A2. A1 and A2 is the centroidal distance. Centroidal distance, where do you get that value? Centroidal distance, it's not act at the loading point, it is some other place. Okay. So here we want to find that equation using this formula. The formula is that L A1 A dash by 3 or L2 A2 dash by 3. A2 dash by 3. That means this is your L value. This is your L value. Then you want to find the centroid of this area. It is not a perfect triangle, or it's not a centric triangle. So you have to, the centroidal distance is some other place other than A1. So you have to find it using L1 plus A1 divided by 3. That is the equation. So you can find the centric value. Areas also you can find. Then A1, A2, etc. Then MC. Next step is MC. How do you find MC? MC is a moment at the point C. In point C, we can see that there is a, if it is an end support, it becomes 0, but it's not an end. After that end support, there will be a 20 kilonewton. So you have to find a moment due to this 20 kilonewton. What is the moment due to this 20 kilonewton? Make a section at this point and find the moment value, and it is a hogging moment. So the value 20 into x. When x become 2, the value 20 into 2 and minus, because it's a hogging value. So the moment become minus 20. Moment become minus 20 into 2, that is 40 kilonewton. Next is the question itself, it's clear that the settlement is 5 mm. So you have to find HC. The settlement only at point C, and it is a negative support. In previous derivation you have considered the C point as above the B and it's taken as positive. Now it is given that C is settled down. So the value we have to take as minus value. Then next step, equate these problems, equate these values. Here again MP is the unknown, the C value already we got it. Then identify the other values and all are given values, then find MP value. After getting MP you can draw the figure. This is the second problem. This is all about our 3 moment equations, problem 1 and problem 2. All are try to do this problem in your notebook. Thank you.